So, on the first page here, 8 through 14. Any questions on 8 through 14? Anything you want to talk about on 8 through 14? Use hands today. We'll see some hands. Anything? Okay, let's just move on to anyone in particular that you want to see. Raise your hand. Anyone in particular you want to see. Dixon, yeah. What number?
23, I think it was.
23?
22.
Find the perimeter of each polygon?
Oh, no. Yeah, it was 23. Yep, 23.
You sound so positive.
Yeah, 23.
Okay. Got this nice faded image of 23 right here. It says find the ratio of the perimeter of PQRS to JKLM. So on number 22, can someone tell me from 22, what's the perimeter of PQRS from 22? Can someone tell me what the perimeter? 58. And can someone tell me what the perimeter is for JKLM? And
68.
what is it?
72.5.
How many people got these? 72.5 and 58.
I got 6.
How many people got these exact numbers? Raise your hand. Own this up. That's a pretty good consistency right there. So if you get the overall perimeters, it's asking you for the ratio of the perimeter of PQRS to JKLM. So that's going to be 58 over. And what does that come out to be? What? Does it come out to be exact? Is it exactly 0.8?
85.5%.
85.5%. So something like this, 0.855, like that. Sounds about right. Did you get that?
I got 0.8.
Is it 0.8? Let's see here. Oh, man. Independent verification on the calculator. Whoa. Okay. Blinking at me. Sound good? In order to find the ratio of the perimeters, you first need to find the perimeters. And if it's going from the ratio between from A to B, it's A over B. That's it. Statement proportionality. So what would it be, Dixon?
DE over PQ
Yep.
equals EF over QR equals DF over P.
Should there be like line segment marks over the?
Yep. You can do that. That would be more accurate. Yep. That's the statement of proportionality right there. The corresponding sides will be, all the pairs of corresponding sides will be proportional. This here, what about 30? Let's go 31. What do you think, Giacomo?
Two isosceles triangles are sometimes congruent.
Sometimes, okay. 32.
32 sometimes.
33.
Sometimes. Yeah, always.
34. What do you think, Ron?
I said always. Yeah,
We'll just see with this. 35.
Always.
36.
Oh, it's always.
Never.
Kyle, 37.
Always.
38. Eber.
Never.
Never. Okay. Anybody want to challenge any of those answers? Giacomo, what are you challenging?
The last one.
38.
Sometimes.
A right and isosceles triangle. Yeah. Do right triangles have to be isosceles?
No, but they can be.
They can be.
What's
So,
an isosceles triangle?
two sides non-hypotenuse are congruent.
Oh, okay.
So, for example, here's a right triangle. Ready? Beep. There's a right triangle. Here's an isosceles and a right triangle. Actually, an isosceles triangle is, you can just say any triangle with two congruent sides. So here's an isosceles triangle. Do they have to be congruent? Can they be?
Yeah.
They can be. They can be. So this would actually be...
I have a question.
Wait. Yeah, so what would an isosceles triangle look like?
A right triangle, both sides.
Yeah, like something like this. Like that. There is an isosceles right triangle. There's one. So sometimes. Anybody challenge any of the other ones? Yes, Will.
34.
34. Two rhombuses. What is a rhombus? What's the definition of a rhombus? Yeah, what's the definition? Yeah.
The definition.
How many sides does a rhombus have?
4.
So 4 sides. What? Yeah.
Parallelogram where all the sides are congruent.
4 sides, parallelogram, all sides congruent.
Oh, since then.
Well, now do you? Do you know what all those words mean?
Yeah.
So you now do. 4 sides. So for example, is a square a rhombus?
Yes.
Yeah, sure.
Um,
All 4 sides are congruent, right? It's by definition parallelogram. Sure. So what about something like this, though? Say one like doot. That side's parallel to that side. This one's parallel to this side, and they're all congruent. Are all rhombuses congruent? No. Could they be? Could 2 rhombuses be? Yes. So this is sometimes. Any other challenges? Yeah. Are they always? No, they're not, because one could be little bitty and one could be really big. So, sometimes.
no, this is similar.
Yeah,
Similar, not congruent.
Oh, is this similar? Are they always, is this similar? Oh, yeah. So they're always similar. I'm sorry. They're always similar because they're always going to have the same angles. Their corresponding angles are always going to be congruent. That's correct. 2 rhombuses, are they always going to be similar? No, because you could change the angles. Can you change the angles? Yeah, you absolutely can. Sorry, similar. Yeah, excuse me. Any other challenges? We're good? Okay, let's. What's the most common thing people forget when they're doing that line right there?
The squared part.
The square, not the squared part.
Of the 27.
Oh, the 27. That's one of the things, but I think there's something else that's more commonly forgotten. Yeah.
Sometimes they try to like distribute the square root.
You could distribute the square, but not trying to solve. Like write down what notation up there do people forget?
Parentheses.
The parentheses. Is this the same thing as this? No, not the same, right? So let's keep on working on this. What do we get? 9x squared plus equals
27.
27 squared. We already know it's 27,
Oh, yeah.
remember,
Yeah,
right?
right.
So how many x squareds do we have on the left? What?
25.
25 x squareds equals 27 squared. So what does x squared equal? 27 squared over what? 25. What do we do to both sides? Square root. So what's the square root of 27 squared over 25? What's the square root of 27 squared?
27.
What's the square root of 25 squared? Oh, sorry, 25. It's 5, right? So x is that. Is that the dimension we're looking for? No. What was the width of this thing? The length? 4x. So how big is this actually going to be? 3 times 27 over 5 by 4 times 27 over 5. How big is that? What's 3 times 27 over 5? Did anybody do this on their calculator? What is 3 times 27 over 5?
81 fifths.
Yeah, it's 81 fifths by 108 fifths. What's 5 into 81? So that's 16 point what? 2 by 21.6. Yeah, there it is. So those are the dimensions of a when we say a 27-inch television. Is it really 27 inches on any side? No, it's 27 inches on the diagonal, right? So Luke, though, what did you say? We figured something out helpful here. What did we figure out? The ratio of the sides is 3 to 4 to. You said there was a different way to do this, right?
Well, the way I was thinking was that you could say.
Listen to this, everybody. Yep.
So you say.
It's okay if it's wrong.
So you have this television where it's 3 inches by 4 inches.
Yes.
And so you make a proportion of 27 over 5 is equal to x over 1 because you're doing x number of inches over 1 inch.
What he's saying is this. He knows that if you're going to blow this up, all the sides are the corresponding sides are what? Proportional, exactly. So if you know that this one is 5 right here, this side right here is 5, what side does that correspond to over here? 5 is to
27.
5 is to 27, as 4 is to, and we could call this L, and this is width right here, as 4 is to what? 4 is to what? L, which is the same thing as 3 is to what? 3 is to W, right? This is what you wanted to set up? So for example, let's solve this. Can you solve for L right now? 5L is equal to what? 4 times 27. So L is equal to? Is that the same thing as we got before? Yeah, look. Is that the same thing? Yeah, it's the same thing. What about this ratio right here. See that? So what does that tell us? What did I do to get from here to here to this step? What's that called? Cross multiplied. Yeah, so let's do the blue blob. You get 5w is equal to 3 times 27. What's that equal to?
W equals.
81 over 5. Is that the same thing? Did we just get it 2 different ways?
Yeah, no.
Absolutely. Yeah. So what does the second part of this say? Are the television screens similar? Well, let's take a look. Let's do the next one here. What was the next triangle? Let's do it the short way. We knew it was going to be 9, 16, and we don't know what the diagonal is, right? But what's this? What's the other triangle we do know? We know that this has to be. What's the diagonal is what on this one? 27. They're both 27. So we know that D is to.
27.
Can we find out D directly? We know what D is, don't we? How do we find out D? I'll start you off. Root 337 over 27 is going to be equal to what? 9 over W, that's correct, equals what? 16 over L. So now do we just have some proportions to solve? Yeah. So if we do that, what do you end up with? Yeah, W root 337 equals 9 times 27. So W equals over root 337.
How do you do that?
Cross multiply. We just did the same. You just told us how to do it. How did I do what?
Get to the.
Yes, L root 337 equals what? Times 27. So L is equal to 16 times 27 all over. Awesome, so we have those. So how do you answer this question then? Are the television screens similar? How do you figure that out? Yeah.
You can just see from the beginning question that they're not similar. If you divide 3 by 4 and 9 by 16, they're not similar.
Exactly. 3 by 16. Well, 3 by 4, that's the same triangle, though. That's
Yeah,
just,
but the ratio to each other has to be equal to similar.
do they? You sure? What we've been writing similar. We've been writing. I agree with you, but our proportionality statements haven't been revolving around that. Our proportionality statements have been revolving around what? Corresponding sides of different triangles, right? I understand what you're trying to do there. That makes sense. But look, our two triangles were this. We knew it was 3 and 4, right, in a diagonal. And we also knew this one was 9 to 16. So if these are similar, what has to be true? If these are similar, what has to be true, Missy? 3 over. Is that true? No. So are they similar? No. Just use the corresponding sets. I totally understand what you're saying. If he's saying if they were similar, 3 to 4 would have to be 9 to 16. That is true. That is true. But I'd rather you do this right here. Does that make sense? Everybody put your pencils down for 1 second. I just want to make sure everybody heard what I said before. This is important. What are the operations you're allowed to do? Can someone tell me one of them? What's one thing you're allowed to do? What's one simple thing you can do? Yeah.
Draw straight.
Draw a straight line. Yes, that's one thing you can do. What's another simple thing you can do? Yeah?
Use the finger as a pencil to measure
Open/close compass to any length. What's another simple thing you can do? You can draw a straight line. You could also draw a... Yeah, draw an arc/circle, right? What else can you draw with just the pencil? I'll give it to you. Draw a point. You can draw a point, a single point. Absolutely. But what can't you? Cannot what? Cannot measure with the ruler. So that's what you can do. I guess you could say 5, you could plot intersection. Type up your steps for duplicating a triangle. And then the second part is figure out how to double the size of the triangle on another piece of paper. Does that make sense, everybody? What I'm asking you to do? How would you make it double the size?
Double each side.
Yeah, so how would you make the triangle twice as big? With just a compass and a ruler. And then the third thing, and this is really the bonus one, draw a 4-sided shape. How do you copy it with the same tools? Your goal is how do you copy any, sorry, this is being really annoying here, any